Alright, to good day everyone. So this time we will be talking about testing the difference between two means of independent samples. So using the t-test. So what is it? An independent samples t-test compares the two independent groups to determine if there is statistically significant difference between them. It is also known as two-sample t-test or unpaired t-test. Used when you have two groups, A and B, and participant in one group cannot be in other. They are independent. The dependent variable is continuous, like test score, height, and weight. So you want to know, are the group means really different, or is a difference due to random chance? So research scenarios. Example, we have here new drugs effectiveness, drug users, placebo group, blood pressure. So this is an example, traditional method, new method, and the dependent variable is the test scores. And marketing impact, if you have viewers, social viewers, and purchase rate. So this is an example of research scenario using this independent t-test. So the formulas, it could be equal variances, assume students t-test. So if that is equal variances, so the formula is this. Okay, we have this one. And sample means, so this is the pool variance. And if that is an equal variance using the student t-test. If that's an unequal variance, we have the Welch t-test. So this is the Welch t-test. And note that the degrees of freedom is n minus 1, n1 for equal variance, and the degrees of freedom for Welch is this one. So practically in some textbook samples, especially small equal sample variances, n1 is equal to n2. People are approximately using smaller n minus 1 df just to make teaching easier. But I want to be accurate, especially in real research using software like Jamovie, SPSS&R. You should let it calculate exactly based on the both variances and both sample sizes. So it could be we'll be using this one or this one. Okay, so we have here equal variances and unequal variances. Well, it's t-test. So common mistakes to avoid: assuming equal variances when they are clearly different, using t-test when your data is not normal and you have sample sizes, using it when the groups are not independent before and after same person used paired t-test. So we have here why independent sample t-test comes into versions. The student t-test assume equal variances and the wall t-test does not assume equal variances. So before choosing which test to use, you need to know that the group are approximately equal variances. So before using this choosing t-test, we have to where the f-test or the differences comes in. So the formula is this one, f is equal to s squared. So we are done discussing how to determine whether it is equal or unequal variances in the previous lesson or discussion. So this one, so the hypothesis, the null hypothesis is equal variances, and the H1 is not equal variances. We have to compute first the F value from the two sample variances. Look for a critical value for F distribution table using this one, or DF1 and DF2. So larger variance over the smaller variance. So you could compare if F is greater than critical value, so we have to reject the null hypothesis, so therefore variances are not equal. If F is lesser than or equal, the critical value failed to reject HO, so the variances are equal. So first thing that we're going to do using t-test, we have two versions here, the student t-test and the Welch t-test. We have to test first the f-test. So before using t-test, test first whether this is one is equal or unequal variances. So that is f-test. So let us have first problem number 1. Two catalysts being analyzed to determine how they affect the mean yield of a chemical process. Specifically, catalyst 1 is currently in use, but catalyst 2 is acceptable. Since catalyst 2 is cheaper, it should be adopted, providing it does not change the process yield. A test is run in the pilot plant and results in the data shown in table. Is there any difference between the mean yields using this alpha 0.05 assume equal variances? So therefore, this is being assumed already that this equal variances. But if we're going to test at one using your f-test, it would result that this is really an equal variance. So because if we're going to compute that one in using your calculator, so the critical value, this one, so our critical value, which is using the here df and df77 here, the critical value is 4.9949. So since the calculated here is around 1.56 is less than the critical value, it falls in the acceptance region. I checked already first whether this one is equal or equal variances. So therefore, it follows that this one is an equal variances. But in our case, before we will go directly, if the given problem is given, is not stated, assume equal variances or not equal variances, we have to test first the f-test, because that is the determiner whether this is this is equal or unequal variances using students or wells. So we have here student equal variances and wells unequal variances. Do not assume equal variances. So this is equal variances. So you could check that one using your f-test whether it is equal or unequal variances. Okay. So sorry. So the first thing that we're going to do based on our steps is we have to check what is our null hypothesis. So our null hypothesis is there's a difference between the mean yield. So therefore, okay, our mu1 is equal to mu2. And we have here our H1 is that mu1 is not equal to mu2. Therefore, this is our claim. Is there a difference between the yields? So step number 2. In step number 2, we have to find the critical value. Okay. So what is the critical value? How to find the critical value? Okay, so to find the critical value, we need to have first, okay, how to find the critical value? So we have here 0.05, and we need to compute for the degrees of freedom. So what is the degrees of freedom here? So this one is equal variances. So therefore, okay, equal variances. Okay. We have to check whether it's equal variances. Our df here is n1 plus n2 minus this one. Okay, minus 2 is equal to, this is 8 plus 8 minus 2, that is 14. So our degrees of freedom is 14, and you have to using two-tailed test. Okay, and we have 14. Okay, this one. So therefore, our degrees of freedom is, since this is two-tailed, our critical value is equal to positive and negative 2.4145. This one, 2.145. So next step is we have to compute the test value. Okay, so we have to compute the test value number 3. Our t is equal to mean 1 minus mean 2 minus 0, because we could equate this one as mu 1 minus mu 2 is equal to 0. So therefore we have 0 over, this is the pooled one, SP. So what is the SP here? We have to count. We have the pooled variance. Okay, this one. Okay, we have to square this one after square root of 1 over n1 plus 1 over n2. So we have to compute first what is our this one. So our pool variance is squared. So we have n sub 1 minus 1 s squared as variance 1 plus n2 minus 1 times variance 2 over n1 plus n2 minus 2. So we have here, this is n minus 1, that's 7, times our given here is 2.39, then squared, plus 7 times 2.98, then squared over 8 plus 8 minus 2. So if you're going to compute this one using calculator, it will yield to 7.30. So since we are looking for this one S sub B here, pulled standard deviation, so square root of 7.30 is 2.70. So we have now the pool variance here and computed. So we have going to immediately solve. So this one this is 92.255 here given, minus 92.733, okay, over 2.70 times the square root of 1 over 8 plus 1 over 8. So if we're going to use our calculator, so we have here negative 0.35. Okay, negative 0.3035. So the next step here is make a decision. So how to make the decision here? We have to graph. Step number 4. So since we have here two critical values, which is negative 2.145 and the other side is 145. So what is our t value? The t value is negative 30 here. Negative 0.35. So if that is negative 0.305 and our claim, so we did not reject the null hypothesis here, but our claim is our H1. There's not enough evidence to support the claim. So what is the claim here? The claim is that the catalyst 2 result in a mean that yield that differs from the mean yield when the catalyst is used. So therefore, we are going to do not reject HO here. So therefore, so if you do not reject the HO, so our conclusion is there is sorry, there is not enough evidence to support the claim. Excuse me for a while. Sorry. Okay, there's not enough evidence to support the claim. So what is the claim? That okay, that claim that the catalyst 2 results in a mean yield that differs from the mean yield when catalyst 1 is used. So therefore, if we do not reject the null hypothesis, so therefore there's no difference between catalyst 2 and catalyst 1. So our claim here is that catalyst 2 that differ from catalyst. So therefore, we could not, there's not enough evidence to support this claim. So therefore, we did not reject HO. So that's all about this one. So let's proceed now with problem number 2. In problem number 2, this is an equal variances using F-test. So we are, okay, assuming that this is an equal variances, but before that, you have to check first using Levin test. If you're using Jamovie, so we could easily compute the Levin's test here by just point click. So later, I'll be teaching you how to use this Jamovie. So since this one is tested already using Jamovie, that this one is an equal variances using F-test. So let's proceed immediately with the statement here using steps of hypothesis. So arsenic concentration in public drinking water supplies is potential health risk. An article in the Arizona Republic Sunday, May 27, 2001 reported that drinking water arsenic concentration in parts per billion for 10 metropolitan Phoenix communities and 10 communities in rural Arizona. The data follows. So this one are the data and computed already that the mean is 12.5 and the standard deviation 7.6 and the other one is 27.5 and the standard deviation is 15.3. So we wish to determine if there's a difference in the mean arsenic concentration between metropolitan Phoenix communities and in rural Arizona. So I've tested already this one. It is very close whether this one is unequal variances, but using the 11 test, it reveals that this is an equal variances. Okay, so the first step that we're going to use is we need to state our null hypothesis. So mu1 minus mu2 is equal to 0 or mu1 is equal to mu2. Our H1 here Okay, our H1 is that mu1 is not equal to here. So we have here our okay, our mu1, mu2 is not equal, so therefore this is our lane. So at alpha 0.05, by the way, this is alpha, here is 0.05. Forgot to write here, na by alpha ni. This one is alpha 0.05. We have to test the statistic. So, but before that, we need to check first a critical value. So how to find the critical value? We have to use, okay, let's go back here. Okay, we have here the critical DF. Find the DF. So we need to use this in order for us to find for our DF, our degrees of freedom. So here, our degrees of freedom is equal to this one over n1 plus n2 over we have over n1 squared over n minus 1 plus, okay, you have to copy the formula given n2 minus 1. So using the competition here, so we have here 7.63 then squared over 10 plus next is 15.3 squared over 10 then squared. Then the other one is that 7.63 squared over 10 then squared. Okay. Over 9 plus 15.3 squared then over 10 squared over 9. So if we're going to compute this one, we're going to have this one as 13.2. Approximately we have 13 as our degrees of freedom. So our degrees of freedom here is 13. So using the alpha is 0.05. 13. Okay, this one. 2.160. So therefore, our critical value is equal to positive and negative 2.160. So that is our degrees of freedom, and we get the critical value. The next step that we're going to perform is that we need to find the test value. Okay. Okay, number 3, we have to find the test value. Okay. So our t is equal to mean 1 minus mean 2 minus 0 over the square root of s squared 1 over n1 plus over n2. So what is our t value here? So our t value is that using the calculator here computing. So you have 12.5 minus 27.5 over we have 7.63 squared over 10 plus we have 15.3 squared over 10. So using a calculator, we have negative 2.77. And step number 2 is we need to draw. Our critical value is negative, positive, and negative. Okay, negative 2.160 and positive 2.160. And again, the result is negative 2.77. So therefore, in this case, we reject HO here. Okay, we reject HO. So therefore, we reject HO because that is in a critical region. Okay, critical region. So if we reject the HO, so if the claim, okay, we will start here that if we reject HO, there is enough evidence to support the claim. Okay, number 5, there is enough evidence to support the claim. Okay, what is their claim here? Our claim in this case is that there's evidence to conclude that the concentration, the mean arsenic concentration in the drinking water in rural Arizona is different. There is enough evidence to support the claim that the mean arsenic concentration in the drinking water in rural Arizona is different from the mean arsenic concentration in metropolitan. Okay, Phoenix. Okay, so that's it on how to find this. Okay, and try this at home. So again, before you will conduct or we will choose the you choose the t-test, you have to select first whether that one is equal or unequal variances. So thank you for listening. Okay, I hope you learned something that there are two versions of t-test, the student t-test and the world t-test. Before going on with the two, selecting the two, we have to use the f-test to determine whether this is student or Welch test, or they're using the 11 test using Jamovi. So thank you for listening and God bless everyone.